How can we make a picture of fluid flow? We can put a dye in our fluid at some point and trace its trajectory. And this way we find a so-called particle path. And using the derivative with respect to time, this yields our velocity field u as a function of space and time. The problem though is that this vector field is changing over time. So in order to make a graphical representation, we usually make one or more snapshots. We freeze time and then make a picture of our velocity field. Using this, we can find the so-called streamlines, the lines along which the fluid is flowing at that particular moment. Let us see how this is done in this video. We start with the particle path. Here we put some dye in a fluid and then it flows along the red curve. So we basically see a movie of a particle flowing. And then at any point we can draw the tangent, which gives us the velocity. So dx dt equals u, the velocity, as a function of x and t. Our problem is, of course, that this is changing over time. So what do we usually do instead? We freeze time, and at that particular moment we draw all these velocity arrows. So these are now for different particles. So there we have our velocities at that particular moment in time. And in order to get a better grasp of what's going on, then we draw what's called the streamlines. Streamlines are then curves which have these blue vectors as their tangents. So a streamline here would start like over here with this tangent, continue with this tangent, move on with this tangent and move on with that tangent. So the streamline would look like something like this. So there we go. That's our streamline. The line along which the fluid is flowing at that particular moment. So how do you find it? You parameterize your curve by alpha, and your dxt alpha, so your tangent, is always given by this velocity u at that particular moment t0. So those are our streamlines. So for every t0 you will get another picture with streamlines. Now, an important case if you have a steady case, if du dt equals 0, so if you are steady, then the streamlines and the particle path are the same. So then our streamline suffice, because then u of x comma t0 is the same for all t0s. And then your streamlines give you the correct image for all time. Now, let us draw some streamlines first. So we take easy flow fields. So we start with u equals constant u times e1. So we only have flow in the x direction and not in the y and z direction. So how do we find our streamlines? Well, dx d alpha equals u, dy d alpha and dz d alpha are both 0. So then we can solve these equations. Well, dy d alpha, dz d alpha are 0, so y and z are constant. And if we integrate with respect to alpha, we have x equals u times alpha plus x0. So there we go. We'll plot them shortly. So we have we are constant in y and z, and x is increasing. Then we take a second example, similar but now slightly more complicated. Instead of a constant u, we now have u equals u in the x direction again, but now times y over a, where a is some constant. Then our equations become dx d alpha equals u times y over a, and dy d alpha and dz d alpha are 0. Well, in principle this could become a mess, because y could be a function of alpha, so then you have some coupled equations. However, in this example, fortunately, dy d alpha equals 0, so y is a constant, so y is a constant, z is a constant, so dx d alpha is again a constant, so x is starting point plus alpha times this constant. Now, how do these streamlines look if we plot them? Well, let's take a look at first. First, we have suppose we start here at some x naught, y naught. Now y remains the same, and u increases if alpha increases, so we get horizontal lines. And if we would start here with another x naught, y not? Y remains the same and x is increasing, so streamline like that. So those are our streamlines. Now what is the difference with the second example? Now in the first example the velocity is the same for all y. Now in the second example the velocity is actually increasing if y gets bigger, so that you would probably draw it like this. So you have again horizontal lines as your streamlines, that's the same. The only difference is that the velocity is faster if y becomes faster, so you usually draw it like this. So here you have this arrow, and then if y gets larger, you go faster. So this is how you graphically show that in the second example, the flow goes faster if you get higher, if you increase y. So there you have your streamlines, and in this case, streamlines and particle paths are the same, because in both cases the right-hand side does not depend explicitly on time. So let's see what happens if we make some messy example where the right-hand side does depend on time, because in that case streamlines and particle paths are not the same. So I took this one, u equals 1t, and starting at 0. First we can find the particle path by integrating x of t equals, well, integrate 1, so you get t plus a constant. Starting in the origin you get t, and y of t equals, then you have to integrate t, so you get 1/2 t squared plus a constant, and by starting in the origin you get 2 squared over 2. So the particle path of x equals t, y equals t squared over 2, so the particle path will be a parabola. Then we move to the streamlines. Then we have dxt alpha equals 1 and dy alpha equals t, so you t naught, so you can integrate, and you have some starting point. So there we have our streamlines, obtained similarly as in the previous examples, which are now really different. So in the picture in the blue, we have our parabola is a particle path if we start in the origin. But how do our streamlines look? Well, if you take, for example, t0 equals 0 and x naught y naught 0, you get a streamline which is just this one over here. However, if you take larger t0s, then you will get still lines as streamlines, but then in different directions. So if you take a bit larger t0, you get, for example, this streamline over here. And if you take an even larger t0, your direction vector will be 1 t0, so it will go steeper. So you get a streamline over there. So in this case, if your velocity field does depend explicitly on time, then your streamlines will be different from your particle path.